guys and girls, and all the rest of the explorers. Welcome back to spaceexplr episode 93. We have a very special guest on today's show. Had a little bit conversation. Part of that was a little bit awkward questions for me, but hey, look, it's all fun. So look, today's guest is Callum Wingrove. So Callum lives in London, and he's also a father to grown up identical twin daughters. That's really awesome. He loves all the things science and obtained a PhD in biochemistry. His interest in space exploration was forged from growing up at the time of the Apollo missions, as you see here. The days he explored the cosmos in his spare time through astrophotography from his home. Video, of course, his work is available on Instagram, and I have a link here, which of course is going to be included in the show notes. So make sure to go and connect with Callum and ask him questions about astrophotography or something else that we will be discussing here. And not maybe, of course, I'm going to be missing something here as well. But Callum, I really appreciate you for making the time to talk with me today.
Thank you very much for the invite. It's much appreciated.
Thank you. It's my pleasure. Again, thank you for doing this. Again, I love everybody who is in the space industry, and it doesn't matter, astrophotography, astrophysics, space science, again, could be anything, engineering. But look, I think space is, I know the space is a very important topic now and will be even more important, in the upcoming years. And my personal mission is just to get as many eyeballs and ears and get them involved in some sort of a project in the space industry, because if we want to achieve great things, it requires manpower, right? You're working part of the financial industry, and it's only you who does all the work. Of course, you do a lot of important things in the company, and you're an important piece there too, but it's a collaborative effort of all these smart, intelligent, passionate, driven people, right? So that's what it's all about. So look, I want to ask you about the background. And again, we're looking here at Apollo 11 mission, and that's where it's all started, right? So
yeah, so
can you
giving away my age a little bit.
Here you go. That's no problem. Look, not with this audience. Look, can you talk about what was the beginning again with Apollo missions? Did you take it from there with astrophotography? You continue where this all thing started for you?
I think the Apollo missions. I mean, I'll be honest. I was 3 years old when it happened, and
there you go.
The only reason I remember it is because my mother sat me down in front of this old black and white television, and she just kept saying to me, remember this, and I didn't understand what was going on. I just remember the grainy image of Armstrong coming down the ladder and stepping onto the moon, and I only remember it because she forced me to remember it. But by the time I was 5 years old, I had posters on my walls of the Apollo astronauts, the Saturn V schematics, all that kind of thing. So I think, it sort of sparked in me an interest in science and technology and, what was possible. Because at that point, it kind of seemed like the world was kind of grey in the 70s. It wasn't a particularly great decade to be sort of growing up in. That kind of changed when we went into the 80s, and it suddenly seemed to be an explosion of colour. But it did seem like, from a science perspective, there was a lot going on. And of course, we finished the decade with the sort of space shuttle, being launched. So, it sort of just sparked in me an interest in science, which I carried through my school years. And at school, we had a teacher who would organise stargazing nights, and he had like a really old brass refractor, but it was good enough to see the sort of cloud belts and sort of a little bit of the colour of Jupiter and the rings of Saturn. So, between that and, the BBC Sky at Night, and also science fiction, which was great, during the 70s, we obviously had Star Wars coming along. I was about 10, 11 years old when that came out. It was just like an explosion of sort of, what's the future going to look like? And there were lots of possibilities. So that just drove an interest in science for me, which ended up, with going to university and studying biochemistry. But I've always had an interest in all aspects of science and space science and physics, and so I've kept up, you know, reading literature and so on and so forth. But it wasn't until a few years ago my daughter's sort of starting to be off at university and, you know, not taking up a lot of my time. My wife asked me, what would you like for a birthday present? And I immediately said I wanted a telescope. And so I chose a telescope for her to get me. And, you know, it kind of then snowballed from there that, you know, I now have 4 telescopes, and an interest in photography and trying to get, you know, learn as much as I could about what's out there, and also to try and communicate through the pictures what's out there and how accessible it actually is to people to go and capture these fantastic objects in space.
Exactly. Carpe noctem, right? I don't know if that's the right to say.
Absolutely.
Yeah, yeah.
Yeah, it is.
Seize the night. Seize the night,
Exactly.
right?
That's on my Instagram profile. Carpe noctem.
Exactly, exactly. So this is awesome. This is awesome. Like, of course, I think the biggest events, like one of the biggest events, pretty sure, like everybody will think about when it comes to the space industry, and uh, like the Apollo missions is definitely there, probably the number one, and a lot of people got inspired from that. Of course, the space shuttle program that followed, and now we have so many different things coming up, different missions. We planning to go back to the moon again with the
Yeah.
Artemis missions and things like that, which of course is super exciting. So, like, how did it work for you? Because again, you ended up working in the industry, which again is biochemistry. So why have not you picked something that would be kind of close to astronomy or astrophysics? Like, have you what the thought
Yeah.
process was behind that?
Well, I think it probably, like for a lot of people, you know, it came down to a teacher at school.
Mm,
You know, we had a really great teacher who happened to be a biochemist.
okay,
And, you know, teachers can sway you
influence.
in a particular direction if, you know, and he was just a great teacher. And he kind of inspired me to go down the biochemistry route. Um, back then you were sort of limited to doing something like 3 A levels for entrance to university. And so I ended up doing biology, chemistry and maths rather than physics. But, you know, it's difficult if you've got a general interest in science. You know, science these days, you specialize into such niche areas, right? No one can know all of science, you know. So you know, I had a love for biochemistry as well. Yeah, I couldn't be everything. So
Yeah.
space science is much more of a hobby.
Mm. So a stupid question. Look, if you would go back into the times, would you still
mm.
choose the biochemistry or would you choose something else?
um, I've actually thought about that question quite a bit. Obviously, I can't go back. Laws of physics don't allow that. But yeah, I have thought. You know, if I was to do it again, I might end up doing physics and maths and going down a sort of astrophysics route. It's funny because these days, we were talking beforehand. I work in the financial services, and you know, there's many of us there who've got PhDs.
Hmm.
In a range of subjects, and there's a lot of mathematicians,
Hmm.
but also, you know, we've got particle physicists. You know,
Finance
it
engineer,
kind of
yeah.
sucks in that sort of cadre of people, you know. So it doesn't necessarily mean I would have ended up in a different profession, I suppose.
Yeah.
But yeah, I mean, if I did it differently this time, maybe I would have gone down that route. Who knows?
So let's say just imagine if you would be doing the astrophysics part and not working in the finance industry, what type of work and research you would be conducting? What do you think that you currently seeing it? I think would be worthwhile to do a research on.
Oh wow, that's huge. I mean, there's all of the sort of I find the stuff about dark energy to be really
Mm,
interesting, you know, because it's just something it's just not known.
yeah.
Um, so and there's a lot of scratching of heads around that. In fact, there was a point, I think, you know, I can't remember when it was in my life, when the physicists I knew at university were kind of like, well, physics is kind of done. we kind of know what it is now, right? They kind of, you know, the standard model and all that, you know, and now it's like, well, we're not certain we really know anything anymore. You know, there's all these sort of discrepancies and things that need to be explained. So there's a whole range of different possibilities that you could go down, from the sort of cosmological interests to, you know, some of the areas which you've got the James Webb telescope that'll be going up, that'll be driving a whole load of new research when it finally goes up and we can start getting data from it. And then you've got the things like the moon missions, which are a stepping stone to Mars. You know, there's so much going on in space science at the moment. Who knows what I would have ended up doing.
Exactly. Yeah, just have you probably seen the recent article? I seen it by BBC about the fifth force of the nature is being
Yes, I saw that. I mean, it's still got to get to the sort of level of statistical significance to be valid, but you know, there's enough people who are excited about it to think maybe they'll get it to that level of significance. And then that's the great thing about science, right? You know, I have friends who think scientists are sort of know-it-alls, with, you know, because we've got this, well, we know this, but actually the most exciting thing in science is when you find out something you don't know, because then that just sparks a whole new line of inquiry that you can go down. So I think the best scientists are the ones who go, we don't know.
Oh yeah. That's for sure. Because look, again, you having a PhD, and I'm pretty sure you're well versed in, you know, biochemistry. I know a few things in that particular niche. You can say, listen, I know, I read enough, you know, I did enough research, and I have these papers to prove it that it's right. But as I say, like, once we go along with this time that we have, like, we still uncover, like, there's a lot of theories that we have, again, about the string theory and different things. You know, what is going to happen once you're going to be in a black hole? Are you going to come out at a different end of the universe? And like, we have all these theories. Why we here? We have certain theories, but we, at the same time, we're just figuring things out because we don't know. Like, by the universal standards, we've just been here a few seconds, you know, and now we just picking up and trying to understand. We have technology to back it up, and we have a lot of smart people just like yourself who are working in different parts and industries. So, like, on that note, do you believe, because again, financial industry is really driven in this day and age, like we live, like it's needed. It's probably one of the biggest industries, probably following the medical fields and, you know, that type of stuff. So do you believe that there's a lot of smart, I remember I looked at this hedge funds. It's been run by Jim Simons. You probably heard about him before. I don't know. So he's one of the wealthiest people. I think has the most successful hedge fund, and he's a really, really smart guy. I mean, I'm not sure he has a Nobel Prize, but I think he's a physicist. And, you know, he hired a lot of smart people, including astrophysicists, people from NASA. And, you know, he has probably the best people to run the hedge fund. And it's a quant hedge fund. So they do, again, the calculations driven by data. So do you believe that all these people that working in this industries and getting paid, you know, really well, do you think that these people should be working in a science field and doing some really important research and maybe getting paid less, or do you think these people, you know, just kind of looking for the
I mean, like I say, I mean, I obviously switched from biochemistry into the financial services, so, you know, money is a factor there. You're young, you've got a family, you know, science can be short-term grants, you know, and the pay is not necessarily great. So, you know, I understand why a lot of people have sort of moved across and used their transferable skills to work in financial services. And financial services is a necessary thing for the world to work, you know. You know, you need funding, you need to be able to finance to do stuff. So it's important. But, you know, all these people with all that intellectual capital, it would be great if we were living in a world where they could use that to further their interests in science and further science and society as a whole, you know, in a different way. I mean, some people would still be needed for financial means, but yeah, it would be great if we lived in that kind of society where there was a balance, and all that training and skill set could be put to use in a way that people felt well remunerated, and had a career path that was going to take them somewhere. But there's a lot of people in the world, there's not enough science positions, etc. And I know from personal experience it's tough, going for grant after grant after grant. It can be challenging. So
well, there's definitely not a lot of scientists who drive a Ferrari, it's unless it's a scientist who has his own company, so that maybe that's the case.
Yeah,
but
some do. I know a couple that do and have done very well for themselves, but
it's just a couple.
That's exactly. It's not the norm.
It's coming back to the point, as I'm mentioning, that those people are not being financially incentivized enough, probably because, again, we're living in an economy that is financially driven. And now, again, with the COVID and the entire, job situation, we've been exposed into how financially fragile we are. Like, if you're going to look at the statistics, again, this is not a financial show, but a lot of people, probably in the 90%, and maybe you can prove that if you know the statistics, like they live from paycheck to paycheck, as the Americans like to call it. So we have a really tough situation, like, money management, earning enough money. So it's a big piece, So I think a lot of people, like in a science field, like coming back to the Jim Simons, where they saw an opportunity making 100,000 a year, working in a laboratory doing some sort of a research and maybe finding an answers. Maybe you will run off the money for the project, or working with a company just like Jim's and earning probably 7-figure income a year. I mean, it's a clear choice for those people, so, which again, it's a shame at the same time.
No, I agree.
But
I think science has, we've progressed a long way in the past 400 years since the scientific method became more established. And, if you think about how things have changed just in the past 100 to 150 years, in terms of our understanding, it's just phenomenal how successful the scientific method has been. And, some would argue it's also led to some damaging things to society. But I think on balance,
including what?
Well, I guess it's led to the creation of technologies which, on at first glance, seem to be good for us. Like the creation of plastics and things like that. Now we know that that's not so good, and we're trying to undo some of the damage, hopefully, from that. Obviously, you've got the whole nuclear question, etc. But I think on balance, it's improved people's lives. You just look at how life expectancy has improved over time, and that tells a story that we're living in a better age. And the fact that we've got a pandemic and we've already got vaccines, and we're able to roll those, or hopefully we're able to roll them out quickly. I'm obviously speaking from the UK, which has had a good experience so far. But I think that goes to show how the technology is helping to get us out of some of these problems that we face.
Exactly. So one of the guests that I had previously on the show, he said a really great analogy when I asked him about artificial intelligence, which is again is a big topic these days. Also, I'm sure you use a lot of that, at least to some sort of degree in the financial industry. And he said, look, it's just like a dynamite was before. It was used to create the roads that we have today, and it's still at the same time is being used for the bad at the same time. So like with the science, as you talked about the nuclear power, or the plastics, like nuclear power, like I had one of the guests where we talked about the plasma physics, fusion energy, tokamak design, like engines and things like that, which of course like we learn, like that's what it takes for us as people, is to learn from mistakes. And sometimes we're good at it, sometimes we do repeat those mistakes, but I think those mistakes drive the forward, the innovation. Again, as you talked about, plastics is a huge problem, and now we're looking for alternatives to
Yeah.
create something, or at least to, how we're gonna, reuse that again. So, we create the problems, but we're good at solving those problems at the same time too.
Yeah, it's one of the key things, learn from failure,
Yeah,
you know. It's
exactly.
yeah.
So besides the Apollo mission, you mentioned kind of, influential kind of moments in life. What do you think besides that kind of stood out the most? Again, space shuttle missions for you personally, back in the past, that you think that was kind of the moment that changed, like with Apollo missions, the moment that it changed kind of the industry for the good.
Um, so in what sense?
It doesn't have to be a global something, because I'm pretty sure like nothing is bigger than Apollo mission, but just on a personal maybe
True.
level.
That's absolutely true. Nothing's bigger than Apollo. No, I suppose on the space sciences side, it was the I mentioned earlier, the space shuttle coming afterwards, because the ability to reuse something, take it out into space, reuse it, and then build the International Space Station. Obviously, there was it was the Mir space station, I think, before that.
Yeah.
And there was sort of a sort of joining up of the Russian and Americans, which sort of led to the building of an International Space Station. And I think the ISS is actually one of the great things that mankind has built. We perpetually have these astronauts up there, circling our planet. To live in an age where that's possible, it's and they're from all different nationalities, so it really is sort of an international effort. And in some ways, hopefully that's the future, showing that people can work together from different nationalities. And I think that's, again, one of the things about science, that it's very much an international endeavor. So scientists publish into journals, and it's freely accessible to anybody to access and to challenge and to repeat and to establish what's really going on. And I think that kind of endeavor is what humanity needs to try and break down some of the boundaries that separate us.
Exactly. That's a big topic. I spoke with a few people not long ago about having these boundaries. And part of that is we have, as we talked about, Artemis mission, are we planning to create sustainable living on Mars? Maybe other planets going, further in the future. And we're talking about the boundaries. And again, being a great example, as I mentioned, the space station, which again, you have multinational people, astronauts working together, trying to find, doing the testing and trying to find some answers to some things that could be really applicable here on the planet. As a lot of the great research came through the, space shuttle mission, the Apollo mission. So, but I think it could be a huge problem that we can face going further in the future. Again, imagine the situation of taking million people on the Mars, or creating, as people like to call it, space tourism. Like, where do you picture it? Do you because I'm pretty sure, like by looking at Elon Musk, as far as he says, timeline 20 years from now, going to Mars. How do you picture, again, having all this experience, again, going back from the Apollo missions to what you're going through right now? Like, do you feel that this is achievable? We can have the sustainable living on Mars, or do you think this is something 100 years from now that could be achieved?
Well, I'm not a huge fan of Elon Musk in some ways.
Any reasons?
But well,
Starlink.
I mean, I'm not saying he's a bad guy or anything, right? So I think he's doing great things, and he's pushing the boundaries, and I think that's all great, I think he needs to. I think it is necessary to try and set these ambitious targets, because if you don't, you never hit it. It's like JFK saying that we'd go to the moon within 10 years. I mean, it literally was like moving a mountain to achieve that, and it's amazing they achieved it. And the fact that Artemis is having to rediscover how to do it in many ways, because all that technology, we weren't going to build a Saturn V rocket again. I mean, it was pretty dangerous. what those astronauts did. But the fact that we're having to rediscover how to do it and how to do it safely, is a testament to how big and ambitious it really was in the 60s to put a man on the moon. And I think Mars, I'm kind of with Stephen Hawking on this, that we have to establish a base outside of the Earth, for the long-term future of humanity. We can't be on this one planet, It's difficult to know when the next extinction event will happen, but we just know it will happen at some point. We've got a much better chance of surviving into the future if we're somewhere else. And so I'm kind of with them that Mars is probably the most obvious choice to go to, and I think we do have the technology to do it. And I think Musk is just trying to push the agenda as hard as possible because he knows how difficult it's going to be. And the first people who go to Mars are probably going to die there, to be honest. Probably not of old age either. I think it's going to be tough. But in the same way that, we've expanded across this planet, and the first people to do those expansions, it was tough. I think the same will be true of Mars, but we'll be able to achieve something.
Yeah. It's definitely like when I talk about people that there should be some sacrifices along the way. Like, of course, nobody wants to hear that. Like, just like you said, probably people will die. The first ones who will go on Mars, because of course we have a lot of scientists who are backing all the data, the research, again, what the Perseverance doing now, and we kind of understand the atmosphere, the way it works. There's earthquakes, we can predict some things, but there's so many different variables that we cannot think about because we never set our foot in there. It's not like Moon that we've been before. We walked around, we drove with this buggy before. We kind of know where things are, and we have a clear map, and we can actually see it by looking in the night sky. This is a planet that we never set our foot in before, and there's so many different things that we cannot think probably about. So look, nobody likes that sacrifice part, but I think it has to be done, as you said, because of the sake of exploration, us expanding in the universe. And it's a very tough topic. The question is, should we take care of the planet first? Maybe, is this was kind of the exit plan, and okay, forget the planet, and now let's move to the Mars and let's occupy other planets. And like it's
we've got to do both, right? We've got to do both. It's not either or. We've got enough money and enough intellectual capital to do both. So I think we can look after the Earth and we can go to Mars and make sure, because if we don't learn the lesson about looking after the Earth, we're not going to look after Mars either. So we've got to do both. We've got to have two homes, and obviously, hopefully, we'll have a base on the Moon as well, which will be permanently occupied.
Exactly. It's very interesting, like, because you coming from financial background to, again, working in the finance industry, when people start talking about, there's not enough funding for the projects, and especially like NASA, and I think now in a Biden, times, I think for another fiscal year, I think it's going to be like $24 billion or something. They're going to kind of projected budget for NASA projects as well, which it's getting eaten up by, I think, just in a month time. Because again, they're feeding the past projects, current projects, and maybe some future projects. And $24 billion, you think about, people and the taxpayers, oh my God, where my money is going? Like 24 million comparing to 200 plus 24 billion comparing to 200 plus billion that's getting funded for the for the armies and for the military stuff. It's nothing comparing to that. And again, talking about not enough funding, where we have federal reserves and banking systems where actually money is created from nothing, because that's the way it works. Again, when we're talking about mortgages, again, this is not a financial show, but somebody who is interested into how the system works, you can actually go and explore and see. So we actually are capable of printing and creating our money from nothing, from thin air, right? So, and we don't have enough budget to dedicate.
That's not a long-term solution, though. Printing money from nothing. It's
So it's very interesting, because look, I think we should dedicate a lot of the capital, we should allocate a lot of capital into the space industry, and to make sure that we continue to feed it. Because again, if the people just like yourself who are really intelligent, smart, they're looking to work in a, you know, in the space industry, they're looking for those financial incentives. They want to drive a Lamborghini while being a scientist. That's
Yeah.
the today's scientists, how they look like, right? So we need to incentivize those people instead of, okay, let's work in the finance industry, of course, which is very important. That's how the economies are being driven, you know, these days. But we just need to probably allocate more time, effort, and capital to those
Yeah.
people, you know.
Well, actually, if you look at what Musk has done to sort of capitalize on reusable rockets to be able to do launches, which he can charge for, you know, it is possible to generate an income from the technology around space.
Takes a
And
long time though.
oh yeah, it takes a long time, and it takes deep pockets to get off the ground. But fortunately, he's got those. You know, but that is the way forward, right? That you've got entrepreneurs like him, and it's not just him. You've obviously got Amazon, Jeff Bezos,
Richard Branson, yeah.
yeah. So they're all trying to do this, and you know, I think the technology that will be developed will have applications here on Earth as well. You know, so you know, I've seen things where they're talking about 3D printing habitats on the moon, for example. You know, using the regolith to actually build habitat structures. You know, you've got to figure that something like that might have a use here as well. So, you know, you could commercialize some of this stuff, I'm sure.
For sure, for sure. Like reusability is definitely a must, and you know, space industry. Just coming back to the Apollo missions, we cannot drop any of these boosters anymore into the ocean. You know, when the infrastructure costs millions of dollars, you know, reusability is a must. And I think, again, as I mentioned, 3D printing, because I know they do. There's companies in UK, because UK is actually, they do a lot of, they have their hands full in the different parts of the space industry. I've seen a lot of great companies coming up, and they're creating you know, 3D printed rockets and things like that. So UK is really being part of it. I mean, the entire change, which is really great to see. So like coming back to the point that of course we want to talk about, and for the people who are watching here and thinking about, okay, space is great, exploration is great, I don't know about the space tourism because I don't have an access of 250K for now, at least, to fly in a lower orbit. What about exploring space from my home, from my backyard? And again, that's where the astrophotography comes in. So can you tell people, what does it take? What type of budget do they need? And how do you get started in this?
Okay, well, I mean, I'll tell you how I got started. So I got a telescope. Well, I asked my wife to get me a telescope for her birthday because I wanted to be able to look up at the night sky. My kids having gone away to university, so I had more time. And I started out with, I found online, it was a 5-inch reflecting telescope. It was called a Celestron 130 SLT, which came with a go-to mount, because I you know, I live in a Bortle 8 area, so you know, you don't see that many stars in the night sky, and I figured having a go-to mount would help find things.
So, so if you don't mind just stopping you and ask, so, you know, this is the show where I stop people a lot, because I just want to ask, why particular dish choice? Like, can you explain people why you chose this, like this model?
I did some research, and I you know, obviously there's a vast array of different telescopes you can get. And I was looking for a telescope rather than a camera lens at that point, because I wanted something I could look through. And you know, I think what I was looking for was best bang for buck. At that point, I didn't know whether this would be something that would sit in the corner a lot of the time and not get taken out. I wanted it to be portable, so it was easy to take out, so lightweight. And I wanted it to have the go-to capability, so I'd be able to find things. I wanted it to be easy, so that you know, I wasn't frustrated by it from the outset. So it wasn't important to me to get the best quality telescope. I just wanted something that was functional and relatively easy to use, but not bottom of the range type thing. So I think this thing was, when I bought it, was £350. I think it's probably £400 pounds now because of Brexit and currency changes and
Yeah.
things like that. But so it's not cheap. It's not down at the sort of £70
And
sort of level of.
and it's a brand new. You bought a brand
And
new.
I bought it brand new. You know, it was, for me, it was, I suppose it's this question, you know, what's the right first telescope for someone to get? You know, and the proper answer to that is the right first telescope is the one that leads you to get your next telescope. You know, and so in that regard, this telescope did its job. I still have it today. I still use it sometimes for planets because most of my setups are wide field. And at 650 millimeters, it's the longest focal length I've got. So I'll still use it for planets, but I put it on a different mount because the mount that came with it, if I'm honest, is you know, that's where compromises have been made.
Yeah.
But it's good, you know. It allowed me to have a decent aperture. You know, looking at Orion through it is a pleasure. The moon's very good through it. You can see the rings of Saturn with it, and the cloud belts of Jupiter along with the Galilean moons. You know, so you can get some nice views. You know, but I think what it led me to was I kind of realized that people were able to use these telescopes to get much more information that our human eyes just can't absorb. You know, there's a limit on visual observing, given the sensitivity of our eyes and the fact that, you know, color vision isn't very sensitive anyway. So after about, I don't know, 8 months, 9 months, I connected a DSLR up to it and took my first picture of Jupiter through it. And it was a terrible, terrible, terrible picture of Jupiter, but it was enough to see the colors of the cloud belts and the blurry red spot there. So, you know, from there, it's sort of, I added Saturn and Mars. But then I realized that it wasn't great to do anything else with from a photographic perspective, because it was on a what's called an out-as mount, which is fine. It can track the night sky, but it doesn't really deal with the rotation of the Earth and how the object rotates as it goes across the night sky in this sort of arc. So it's not good for long exposures. You know, you might as well just have a camera on a fixed stand, and you know, after about 20 seconds you start to get, or even 15 seconds, you'll start to get star trails and things like that. So you can just about photograph the Orion Nebula because it's so bright with it, but it was limited. So from there, I kind of started doing research on what else could I do if I wanted to expand, because obviously deep sky objects, you've only got so many planets you can photograph, and even with the biggest telescopes that you're likely to have as an amateur, things like Neptune and Uranus, you're not going to resolve detail on those planets. They're so far away. So Venus, Mars, Saturn and Jupiter are the ones you really are going to get some data on. But deep sky, you've got vast amount of things you can photograph, from galaxies to supernova remnants to nebulae. I mean, it's just, space is littered with this kind of stuff. So, you know, I figured that's where I would go next. I did a lot of watching of YouTube and reading websites and things like that. So, you know, things like the classic ones, Trevor Jones and his Astro Backyard, and Chuck's Astrophotography, you know, and various people's websites who were astrophotographers. And I ended up then purchasing an 80mm refractor and an equatorial mount, and doing some shots with that with the DSLR, before adding an astro camera, a dedicated astro camera, and then, you know, auto guiding and computer control and all this kind of stuff.
So can you explain to the people, you know, differences between regular DSLR and astro camera? Like what is the main difference there?
So the main there's two differences. You can get the astro cameras with cooling, You can get them without, but I'd always recommend, if you can stretch your budget to get one with cooling, it's well worth it, because the cooling will remove the thermal noise, because you're taking long exposures, maybe up to 5 minutes. That's kind of the longest I go in my light polluted skies.
And you
You know,
live in
sensor can get hot. I'm living in Bortle 8,
wow, okay.
so you know, it's a bit washed out. Actually, to the north, I'm kind of Bortle 7, but I've got my house in the way of the north, so I don't normally. I'm normally pointing between the southeast and the southwest, and that's kind of pointing into London's sort of light dome. So I do have to deal with light pollution quite a bit. Yeah, so the thermoelectric coolers you can get on the Astra cameras will help keep the sensor down to a nice frosty -10 or -15 degrees, and remove that and help reduce that thermal noise. With the DSLR, you can't do that, and you tend to get a sort of red blotchiness in the images, which is the thermal noise triggering electrons, registering and creating noise. The other thing is that the DSLRs, an unmodified DSLR, has like an infrared cut filter built in, and that is generally going to block a lot of the light from hydrogen in space. So hydrogen is in the infrared. You still want to keep the far infrared blocked, but unfortunately the DSLRs will be blocking the infrared you actually want, or the light in that wavelength that you actually want. So, you know, I pointed my camera, which was an old Nikon D3100, which my wife had bought about 10 years ago, at the Rosette Nebula, and I shot a bunch of 5-minute subs, and I stacked them, and all I could see was stars. I could not see any of the nebulosity at all. So an Astro camera doesn't have that problem. It's sensitive to that light, and you know, the same. I can point one of my Astro cameras at the Rosette Nebula, and I see all this nebulosity within seconds of pointing it at the nebula. So it's actually very bright to an Astro camera. So, you know, the Astro cameras, and they're different manufacturers. I happen to use products from a company called ZWO, but there are other ones, QHY, etc., and they tend to use the same sensors. So which one you go for is really down to you, I guess. I have a particular reason for using the ZWO, because I use another one of their products called the ASI Air, which is like a little Raspberry Pi based computer, which helps me control everything. And it will work with a range of DSLRs, but when it comes to Astro cams, it will only work with ZWO's own Astro cameras. Obviously, you know, they're a commercial organization. So, you know, I find them very good. A lot of people use them. You know, I think they do make very good products. So yeah, an Astro cam will just add to your ability to capture these nebulosity. Obviously, a standard DSLR would be quite good at broadband targets like galaxies. So Andromeda, for example, will be quite easy to capture with a DSLR. But if you're going for those nebulas, you either need to modify the DSLR to remove that filter, which is possible, or get an Astro camera.
Got it. So upgrading the camera DSLR and going to the Astro camera, you know, taking the piece out, is that gonna mess up the daily usage of the camera? I mean, is this not non-reversible, or you still can use it?
Yeah, I think it does kind of mess it up, because I think I've seen people take pictures with Astro cameras, you know, sorry, modded DSLRs.
Yeah.
And they can actually take these really beautiful pictures. You're seeing all that infrared light, so the trees no longer look green; they're sort of a sort of whitish color. So yeah, it's
unless you prefer that look.
Yeah. But I think Canon make DSLRs like the Canon RA, which is sensitive to the nebulas, but can be used as a normal camera. So I don't know. I've never really looked to that. I know Trevor Jones uses the Canon RA, and I know a few other people who shoot with it, and it's very sensitive to nebulosity. I don't know whether it operates like a mechanism to switch the filter in and out to provide that capability.
Got it. So I mean, when it comes to the budget, I mean, you can go as low as, a couple $100 or $100,000. Like you having right now, you said like four telescopes, four different telescopes. Like, what would you recommend as good an entry point? Let's say for somebody who has, let's not call it a limited budget. They have, some money in a bank account, and they went from phone DSLR, and now they're looking to get into, buying
Yeah.
equipment. Like, what is a good starting point and a good budget to start them?
Well, I think with astrophotography, it's quite a technical pastime, and you want to try and make it as easy on yourself as possible. And so going for a wide field setup, which means something that's not going to zoom right into the center of the Eagle Nebula, for example, but something that will capture the whole of the nebula and possibly the space around it. It's going to be a lot more forgiving for someone beginning this hobby, because taking long exposures requires you to overcome a number of technical challenges. You need an equatorial mount that will compensate for the rotation of the Earth, and that needs to be precisely polar aligned so that you can take these long exposures. But you might find that you also need to guide the mount to remove errors in its tracking, etc. And with a wide field setup, those errors are going to be minimized hugely. If you go and buy the biggest telescope you can find, you're going to find it really, really tough to track the night sky accurately. I have seen people make that mistake of going out and getting a really big telescope and then getting very, very frustrated that
because bigger is better.
Yeah, exactly. Before learning, all the things that can go wrong with astrophotography, and then they're really struggling to get it to deliver something that's good quality. So, I mean, my first proper telescope after the Celestron was a Skywatcher EvaStar 80 ED. So it's a doublet telescope. So its price point is very, very reasonable in terms of the quality of the images it delivers. It has negligible chromatic aberration. It's I say 80 millimeters. It's got about 500 and with the reducer, it's about 520 millimeter focal length. So it's quite wide field. You can get a lot of targets that fit inside its field of view, and it will be very forgiving to a beginner, and it doesn't break the bank in that sense. So I was really happy with it. I'm still going to use it. It's a great telescope.
So the mount, what about that? Would you still recommend people to go with the altazimuth or equatorial? What's the right way to go?
For deep sky objects, I'd go with the equatorial. I mean, big observatories can use as mounts because they can use very complex software to correct, for the rotation of the Earth. But for an amateur, an equatorial mount is probably the easiest way to deal with the rotation of the Earth. And actually, the mount is probably the most important part of the whole setup. So getting a mount that is robust and tracks well and will take the weight of the equipment you're planning to put on it, that's really key, is critical. And there's kind of a rule that, whatever the payload capacity the manufacturer says, halve it. And as long as the weight of your equipment is half or less, then the mount should track well. So, it's a question of doing your research about what mounts are going to fit the equipment you're going to buy. You can obviously future-proof yourself and get a mount that's going to take any kind of weight of equipment, but the cost will be substantial. And if you're not sure whether this is something for you, then you probably want to just go for something that's entry level or just above entry level. I went for a Skywatcher HEQ5 Pro, and it's just a little workhorse, really. It's not too heavy in terms of I can lift it up with the telescope and carry it outside, because I don't have an observatory. I have to do it outside. But fortunately, I've got a place just outside outside the rear of the house, and I can just lift the whole thing up and take it out, and then all I've got to do is line it up on the pole star. So again, another thing is, is it so heavy, the thing you're going to have to take out, you're going to have to assemble it, and get a lot of time spent putting it all together. Being based in London, clear skies is a fairly infrequent thing. I think 10% of our nights are clear skies, which is not great.
Yeah.
So, and it can be, there's a couple of hours, I don't want to be wasting time trying to put everything together. So the fact that I can just carry it out, I can go from it being indoors to carrying it out and polar aligned and ready to go in about 20 minutes.
So what about you mentioned Bortle 8, right? So
yeah.
How do you go about tackle the light pollution? Filters, post-processing? What's the right way?
It depends on the target, I guess. I mean, I really like shooting nebulae because I can use filters, which really help with the light pollution. So,
and you have the new LEDs on the street, or is the
no,
old...
actually we've still got the old sodium lamps, which is
that
great.
helps.
Which is great. In fact, they've just formed an all-party parliamentary group at the end of last year for dark skies in the UK. So they've already started saying this area, that area are going to be dark sky sites, and they're putting in planning instructions for councils as to how to install lighting, street lighting, to minimize light pollution, which is great. And my local member of parliament is on that committee. So I'm hoping that when they do come to put the LEDs in, they'll do it sensitively and not just have light blasting up into the sky. But yeah, I can filter out a lot of light using narrowband filters. So for my color camera, I use what's called a duo narrowband filter. My one is the STC Astro, but there's a range of these things. So Optolong do the L Enhance and the L Extreme, and I suppose my one is somewhere between those two. ZWO do their own one. What kind of varies between them is the width of the bandpass, how wide it is to let light in. So it can be, some of them are 12 nanometers, some are 10 nanometers, some are 7 nanometers. Obviously, the tighter you are, the more specific the light that's coming in from what you're trying to photograph. So you can use those for things like supernova remnants, emission nebulae. They will really help to cut out the light pollution. For broadband targets, it depends. Sometimes if something's up near the zenith, which is the darkest part of the sky, like we're in galaxy season now, it's not my favorite time of the year. I'm really looking forward to the nebulae coming back. But if I'm pointing up near the zenith, then I might just shoot with a UV IR cut filter. So I'm really not filtering out the light pollution, and I'm having to deal with that in post-processing. But that way I at least get as much data on the galaxy as possible, because it's a broadband target. The moment you start using a light pollution filter, you're going to start filtering out some of that, and it starts to become difficult. I do have a light pollution filter I use as well for broadband targets. It's an IDAS NGS1. It works quite well, but I find I have to soak a lot of time to get a good integration and result with it, because it does actually block quite aggressively. So yeah, filters are kind of an essential for high light pollution skies. But I know people who are in Bortle 9 in the centre of London, and they're still able to photograph nebulae with these narrowband filters. So they work really well.
So you mentioned about techniques. So maybe you can share some of the techniques that helped you to do this great, amazing work with the nebulous or the planetary stuff. Can you talk about some things that you found again through your personal experience that work for you the best and could be great for the beginners also?
Yeah, so I mean, I think for the deep sky stuff, I mentioned earlier I use a computerized system called the ASI
Uh-huh.
and that's worked really well for me. And the sort of Skywatcher mount I've got, it is broadly compatible with a whole range of different mounts and so on and so forth. Obviously, as I said, it will work with a range of DSLRs, and but other than that, for the astrocams, you need a ZWO one. But it's kind of like it makes the whole process easier because you can control it through an iPad or your phone, and you've got access to the automation of the sequencing of your photographs. You've got focusing screens. You've got guiding tools. So it's a kind of very simplified version of what someone might have to put together with a laptop, because otherwise you've got to control it with a laptop
Mm-hmm.
if you're using an astrocam. And that requires different software, and it's all got to work together nicely, and you've got to put your laptop outside unless you've got USB cables going through the walls, etc. So it's something I have found personally works well for me. They've evolved it massively. I've been using it for almost 2 years now, if not more than 2 years. Actually, probably a bit more than 2 years now, and it's kind of evolved over time, and it's they're always developing and it's getting better and better. And I've got two of them now. I've got the original one, which still works great. It still takes the latest software, and then I've got the ASI Pro, which has added sort of power management features, and it's got a faster processor, so you can actually use it for planetary work as well. So it can capture video rather than just single images. So it's a one-stop shop that sort of allows you to learn all this stuff using one thing. So you're not really fighting the software as well, because that's another problem you can face with this hobby. So if you're a beginner and you've got the equipment that's compatible with it, the ASI is a very good tool for driving your mount and camera if it's compatible. And learning the basics around guiding and everything else. It does take some shortcuts, so you don't have as much access to, it has Ph.D guiding built in, but you don't have as much access as you would in the PC software for controlling every aspect. But I'm guiding normally 0.6 0.8 RMS, which if you're below 1, you're guiding very well. So I find it works really well.
Got it. So what about the other process, which again is really painful for a lot of people, and the learning curve is quite steep when it comes to post processing images.
Yeah.
So can you talk about how do you go about this part of the hobby from stacking to post processing,
Yeah.
and what's the best for the beginners?
Well, I kind of started out with Deep Sky Stacker because it was free, and Deep Sky Stacker does work. And I used GIMP, which was also free, which is kind of like a free Photoshop. So I was able to adjust the levels and curves and things like that, and try and get some pictures. But I then sort of started playing around to see whether I should go with PixInsight. And I probably made a mistake with PixInsight, because I went to look at it when I had data, but it wasn't really good quality data. And PixInsight has quite a steep learning curve. I don't think anybody would dispute that. You can go and watch hours and hours of tutorials on PixInsight. So I kind of got the demo for that, and I really didn't like it. I didn't like the GUI. The learning curve. It was rejecting all my data, which Deep Sky Stacker would accept. It just wouldn't stack it, and I know it's a fantastic piece of software, and a lot of people, a lot of very good astrophotographers use it. and I might come back to it in the future. Who knows? But I then kind of stumbled across AstroPixel Processor. So this is another paid-for piece of software. You can rent it, so get a rental license which you renew annually, or you can buy it outright. And I found AstroPixel Processors to be very, very good, because it's got a lot of the complexity of PixInsight, but it hides it under the hood. Again, it's kind of got a slightly strange interface that takes a little bit time to get used to. But if you go from DSS, it's quite natural, you know, the stacking process is quite natural, and they've got like a tabbed guide. You go from tab 0 to tab 9, and you just follow the sequence through. You can pretty much use their automated settings, and it will get you a very good result. You know, once you want to, you can start playing around with some of the other settings to see if you can improve the result. But more often than not, you know, 95% of the time, the automated settings will do a very good job. And it has some post-processing tools to allow you to adjust the image. It's very good at light pollution removal. So something which you know is important to me, because I always have a huge light pollution gradient, you know, is very, very simple in AstroPixel Processor. You don't really, it's literally just drawing boxes across the screen and then clicking calculate, and it will work out the gradient and subtract it. So it's very, very simple. And that's an area which kind of stymies a lot of people when they're starting, is how to get rid of these massive gradients. So I find AstroPixel Processor is very good, and that will give me an image which is maybe 90% of what I want, and then I'll import it into Photoshop just to do some final tweaks, maybe a star mask to reduce the stars, that kind of thing, and just clean the image up. So I mean, I think for a beginner, start with Deep Sky Stacker to learn what stacking is. There are some things which it can do which so far AstroPixel Processor can't quite do, like comets. You can stack with DSS. I've had good results with that. I know they are now about to release a comet stacking feature in AstroPixel Processors, though. So at that point, I won't have a need for DSS anymore. But once you've kind of got the hang of stacking and maybe adjusting levels and curves in something free like GIMP, you might want to move on to AstroPixel Processor, because it will make, as a beginner, your life a lot easier, and you'll get better results than with DSS.
Got it. So the question is, because again, you know, there is always a portion of the audience who are really young, and I'm talking about, let's say, you know, 13, 15, up to like 18 years old, and including myself. Look, I sometimes struggle with one thing I think a lot of people do, is with patience. You know, so you talked about, you know, making things automated. So do you have an experience, or maybe you can recommend something that would be kind of fully automated version of, let's say, you know, when it comes to reducing the noise, or, you know, image sharpening, or, you know, something that will be, you know, helpful for the beginners, because they don't want to spend a lot of time, you know, in the beginning stages to kind of figure things out?
Yeah, I mean, there is some denoising tools within Photoshop. So, and they're reasonably intuitive. You can even get Photoshop Express actually on an iPad or something, which is free, and it has a reduced noise thing. So if you really are starting out and you want something easy, you can just load the image on your iPad, and it's got all these free tools in it that will improve the quality of the image. There are other sort of, as you go forward, there are other sort of paid for sort of sharpening and denoising things like Topaz, which uses AI, and that, you know, it's probably 50-50. So, you know, I'll always run something through Topaz and just see, you know, play with the sliders and see if it's possible to improve it. Sometimes it does. Sometimes, you know, you can you can remove noise in the background space, but the stars then end up really blocky and
Yeah. And
nasty.
have you got an experience with the topaz that is actually adding some items on the image that wasn't there before? Have you got that?
Well, actually, yes. When I first started with Topaz, it would add these sort of grid lines onto the image. And I did go onto their forums and people were complaining about that. I haven't seen it for a long time, actually. So I think they might have fixed that issue. Sometimes it will, you know, smooth out the colors too much. It's got a slider for reducing color noise. I generally leave it at 0, but it still manages to reduce the color noise. You know, something in the algorithm is trying to smooth the data, and you lose some of the color. So you know, it works well on some images, not so well on others. But I do have it. It's a good tool set. I actually got the sharpening one as well, which I find can work well with pictures of the moon, for example. When you get them, they might be a little bit soft, you can just tune up the moon. And I've managed to actually, their algorithms do work very well on regular photos. You know, I've managed to take unfocused old images and you know, suddenly they're in focus. It's incredible.
Because that's what the topaz is made for. It's not made for astrophotography. It's just for yeah. But hopefully, because I've been having these talks with some of the astrophotographers, so maybe those people are watching or listening to the communities in astrophotography, you know, astrophotography community, and maybe they will be creating something that will be dedicated more towards astrophotography. Because I know there's a lot of astrophotographers who use it. So,
yeah, it would be great. I mean, the thing is that dealing with noise, it's always better to get more integration time, you know, but when your integration time is so limited, you know, it's you know, I talked to some of the other astrophotographers and they're in the States and they've just got clear night after clear night after clear night, and they've got telescopes pointing up at the night sky, maybe 2 at once, and they're gathering all this data. They then publish a week later, you know, they've got an image with 50 hours of integration, you know, and I've struggled to get 3 hours that week, you know. You do need some of these other tools to kind of help you along. Otherwise it'd just be impossible. Yeah, I mean, I think the most I've ever shot on a target is about 10 hours.
Oh, Jesus.
Yeah. I'm
It's
kind of hoping, year after year, I'll just add 10 hours, 10 hours, 10 hours.
So you start thinking about relocating, right?
I have mentioned it to my wife. She's not really bought into it.
Got it. Maybe in the future. Maybe in the future. Okay. So look, again, nebulas, right? So for people who are gonna go on your feeds, and again, Callum Wingrove, that's gonna be calling in the show notes. So make sure to go in and see Callum's work on Instagram. Like, how do you go about picking the objects? Is that something that you go about? Jump in a chat section in a Instagram community and talk with the people? Is like, okay, what you guys are after, and how do you pick the objects for the nebulas first?
Well, I think when I started out, I got a book which it was to do with CCD astrophotography, but it kind of listed out the various targets through the year, so from January to December, because obviously they rise and fall, you know, the same ones year after year. So, you know, I started out looking at that, and that gives you some idea of what to shoot in the night sky on a given day or week. Also, though, you know, there's other tools like Stellarium or Sky Safari, you know, where you can sort of browse what's in the night sky. The ASI Air also has its own database of saying what's good tonight. You know, I rarely use that, to be honest, because, you know, it tends to recommend things which have already gone behind trees or, you know, things like that. So I plan in advance. I kind of know now, having done this for a couple of years, what things are out there, and I'm starting to think about, well, what are the things that don't get photographed very often, you know, that might be a lot fainter. And so, you know, I might try to try and shoot some more of those objects, or find some more of those objects in the next 12 months. So yeah, it's a case of sort of working out where the Milky Way is, because the nebulae are along the line of the Milky Way. and what's going to be high enough in the sky, because the higher something is, the clearer the image you're going to get of it, and it's going to be away from the light pollution. I mean, I'm hoping at the end of May to be going down to Devon to a Bortle 2 site, you know, obviously for a holiday with my wife, but I'm going to take a camera with me. And I'm hoping to be able to shoot, I can never pronounce it, Ro Ophiuchi, which is this sort of beautiful cloud of coloured gas around the star Antares. And every picture of it just looks spectacular. It's got blues, it's got oranges, you know, it's just this vast thing that sticks out from the side of the Milky Way. But it's very low in the sky here, so I have tried to shoot it from here, and it's just all washed out by light pollution. There's just nothing, and it's a broadband target, so the filters are just no good. But I'm hoping from there it'll be dark and I'll be able to do it. So I was looking at that on Sky Safari. I was looking at, from the location I will be in, what will be in the night sky at that particular point in time. And that one sort of stuck out because I've never been able to photograph it from here.
Got it. So what about in that case? Because I'm pretty sure you mostly use all your data to process. Have you thought about, or would you recommend for the beginners to process the data from observatories where you can actually get the glance of these objects?
Yeah, I mean, I see, I've never done it myself, but I see people doing it. You know, we had a terrible winter here in the UK. It was really rare to get a clear night. And so I saw quite a lot of people actually go over to the things like Telescope Live and stuff and get some images. And those sites are able to produce data that is so clean. You know, some of these telescopes in Chile, it's just incredible what they can pull in, you know, in a matter of minutes that would take us hours and hours and hours to pull out. And it's just beautifully clean. So, you know, if you can get hold of some of that data and learn how to process it, you know, it's a good thing. It gives you some practice before trying to do it yourselves. I mean, the great thing about those is you get to see some of the Southern Hemisphere stuff. My wife is Australian, so I'm kind of hoping at some point after this pandemic, we'll be able to get to Australia and I'll be able to take some equipment with me. And, you know, I really want to photograph the Carina Nebula, for example. But yeah, that would be a whole other thing, night sky I'd have to learn.
Got it.
No, I mean, if you can get hold of data, and some people give their data away, it can be useful as a beginner to practice on.
So look, the question now remains: with the 4 telescopes at your house, you have full equipment loaded. Like, what's the next step? Maybe the home-based observatory is kind of the next thing to think about.
Yeah, I've thought about it. The problem is that the ideal location, I'm actually got trees. I've got these 40-foot trees next to my property, which are my neighbors. And in some senses they're good because they block light from neighboring areas, but at the same time they also block my visibility. And I've got this area just at the back of the house which is perfect for being able to see Polaris and being able to do what I need to do, but it's on a balcony. It's not really suited to an observatory, and my wife would definitely not want an observatory smack bang outside the house. So I have thought of other locations around the house, around the garden, to see whether it would be any good, but I think it's probably going to have to wait till the next house, I think. I did think of putting one in the roof, actually. You know, I have seen some people doing it, but I'm kind of worried about vibrations and things like that. Although down the hill from where I live, there's an old house, Victorian house, which used to be owned by one of the captains, or it might be the first mate on Ernest Shackleton, the explorer.
Wow.
It was one of his crew owned that house, and actually there is this sort of curved structure on the top of the house,
just
because
perfect.
he used to have a telescope which he would do visual observing from his roof. It's all been sealed up now. But yeah, there was clearly an observatory on that house.
That is
a long
amazing.
time ago.
Well, I'm pretty sure his crew is was into observing and into exploring. So yeah, they have to have
Yeah,
it. So
absolutely.
yeah, that is awesome. I will send you a photo because I'm just looking for the photo I have of this beautiful house that's I got from one of the people, and I will send you a little bit later to kind of show you to get an idea and maybe pitch that idea to your wife for the future because it's in a beautiful location. So I'll send you a little bit later.
Yeah,
So
please.
again, with your current work, like what would you say would be a great place for people to go to and see? And when it comes to the best type of work that you did, and of course, I seen an image of some of your work is being. Oh, here you go. So Astro Backyard, so included your Pleiades shot, sorry, Pleiades shot in reviews of light pollution filters. So
Yeah,
that was a good moment.
that was.
So yeah, that is really cool. So what would you say besides this and these type of moments that would be kind of the best your personal work that you think you've done in your career so far?
Well, I'm always kind of critical of my own work. I think everybody is. And I think the more experienced you get at it, the sort of more you find the faults in it. When you start out, you're just grateful to see something, that's a deep sky object or a planet, and it's fantastic. It may be this smudge of red that's actually the red spot of Jupiter. But then you kind of see what's possible, and you're always wanting to try and achieve what's possible and get the best out of the equipment. And it's a battle, from the data gathering to the post processing. There are so many options, so many paths you can go down to get a good image, or you might find that it's not such a good image once you go down a particular path. And I still go back to old data and reprocess. As I learn something new in the processing workflow, I go back to old data and apply it and try and get more out of that older data.
Mm-hmm.
So it's always a learning process. I think one of the key things that sort of stuck out for me was when I managed to finally work out a way to reduce stars effectively. And I applied that to a photo of Andromeda I took towards the end of last year, and it kind of jumped out. Andromeda had been hidden behind all these stars, and suddenly I finally had something that would show the galaxy off in its rightful place. And so, that was a sort of standout moment for me. And now I can apply that technique to
Yep.
nebulae and other things. So yeah.
So as you said, being not a big fan of the galaxies, and again, here we go. Here we have a galaxy season. Still, like any particular objects that you're going to be shooting yourself, and anything that you would recommend for the beginners to pay attention to also.
Yeah, I mean, there's some galaxies which, even with a wide field telescope, they're kind of still spectacular to look at. So the Whirlpool galaxy M51, for example, that is it's quite dim when you first start photographing. You do need to build up quite a bit of light on it, but it's a spectacular thing even in a wide field telescope to look at. The Needle galaxy is very bright. It doesn't need a lot of exposure time. You'll be able to pull out the detail in an hour, even from Bortle 8. It's very small in a wide field, but I shot it just over a week ago, and it'll probably be the next thing I put up on Instagram. I'm trying to get as much detail out of it as I possibly can in the post-processing before I put it up. I think I'm almost there now. So it's just a unique shape to look at, and you can get some colors out of it quite nicely. So within the galaxy season itself, there are easier targets than others. The Pinwheel galaxy is often photographed, but it's actually quite hard. It's really, the surface is quite dim, so you really have to build up a lot, and getting structure out of it with a wide field is quite difficult. So I prefer the Whirlpool over that one. The Sunflower Galaxy is a nice one, but it's again very small, and you kind of need to build up a good 3 to 4 hours of time on it to be able to do it any kind of justice.
Yep.
So yeah, I mean there are a lot of galaxies around. Macarian's chain is a good one actually, because you're not trying to get a lot of detail on it, but you in a wide field you can get the whole chain. Yep. Or most of it, and that's quite a nice one to go after, because you've got this whole chain of galaxies stretching across the sky, and if you frame it right, it's very easy to get. So there's some nice things up there to photograph at the moment. They may not be my favorites, but they're still nice to go after. You know, the technical challenge of grabbing these things and trying to do them justice is what drives it, really.
Yeah, we're going to be waiting for that Carina Nebula that you talked about, before, and getting that image out again. Being fan of the nebula. So, do you say, like, for the people who want to explore the planetary stuff, how difficult would be for the beginner? Again, because I know it's a little bit different from nebula.
Yeah,
imaging.
I mean, I started with planetary, and so it's funny. I started with planetary, and so I find planetary easier than deep sky. Deep sky to me is a lot more involved. There's a lot more that can go wrong. Whereas I've seen people who started with deep sky and then gone to planetary, and they say the opposite. That, planetary is really hard. Yeah. But I think the key thing with planetary is that you're capturing video rather than individual long exposures, because the planets are so bright. So you need to have a long enough focal length that you can actually resolve the planet, and very often that means using a Barlow. So a Barlow lens that will sort of maybe double the focal length of the telescope you're using. I actually found I was able to get quite a good picture of Jupiter by using eyepiece projection, and I also shot Mars last year with eyepiece projection. It's a bit fiddly to get it set up right, but effectively you've got the Barlow lens and then the eyepiece in there, and then you're putting the camera on top of that, and providing you can get that stable, so it's all locked together nice and tightly and it's not moving around, then you can actually sort of magnify, even with a small 650mm telescope, a planet to the level where you can actually resolve the cloud belts of Jupiter quite nicely and get quite a sharp image on the great red spot. So it's about getting that sort of additional focal length that otherwise you need to have a really big 11-inch or 14-inch telescope, which is just going to be humongous. So you can with these sort of smaller telescopes do some planetary, resolve the rings of Saturn, get the cloud belts of Jupiter, see some structure on Mars. It's about finding the right conditions though. I mean, I photographed Mars last year, but it was at opposition, so it was as close as it could be to us. You don't want to be trying to photograph Mars when it's 140 million kilometers away rather than 35 million kilometers away. Also, you've kind of got to understand what atmospheric seeing is going to do, because you're focused on a very narrow piece of the night sky. So that sort of waviness you get in the atmosphere, it's a bit like a heat haze on a road in the summertime. You've got this heat, and it can be perfectly clear, and you point your telescope at the planet and all you can see is this shimmering light, and you're just not going to get a good picture under those conditions. So it needs to be a night where the atmospheric seeing is good, so it's not very turbulent. You can focus nicely on the planet, and then you've just got to capture some video. And once you've got it focused and you're tracking it nicely, capturing the video is quite simple to do. You might want to play around with the gain and all that kind of stuff, but it's relatively straightforward. You just capture the video, and then you can process it with some free software. So there's software called PIP, which is quite PIPP, and I forget what it stands for. But it's you can download it. It runs on all these things, run on Windows. That will, if the planet has been drifting across the field of view, Pip will just create a new video with the planet in the center, so it's then ready for stacking. If your planet has been tracking on a good mount anyway, it probably won't have been drifting, and you can just put it into the stacking software. And there's stacking software called Auto Stackert. There's version 2 and version 3. Version 2 is 32-bit, version 3 is 64-bit. I tend to find version 2 works really well for some reason. So that will do the stacking of the images, so it can analyze the frames, and you can say, all right, well, I've got 50% of my frames are good, the other 50% are not, so I just stack the 50 best frames, and then that will give you a picture of the planet, and then you can tweak that. So there's another tool called Registax, which has some what called wavelet tuning things, which will allow you to tweak the image. But you know, to be honest, I don't do enough planetary work to say I bother with Registax anymore. Once it comes out of AutoStacker, I might just tweak it in Photoshop and leave it at that. But obviously, the more experienced planetary people would probably go a lot more in depth in their post-processing. But for beginners, I think AutoStacker does a fantastic job of just outputting a good image of the planet.
Got it. Okay, so the question, like previously I had on the show a couple people. One of them is Rod Stubbings. Another one is Will Young. And I'm pretty sure I have a few more people. And of course, these episodes are available for you guys if you're going and check them out. And they mainly focus on observations. They do more of the observations versus the astrophotography. So, and of course, I see a lot of people are now joining, you know, astrophotography and taking this as a hobby. A lot of people take it really serious, where you can see 13-year-olds work.
Oh,
And it
yeah,
looks
yeah,
like
yeah.
it's look like what? Like what's happening? You know?
Yeah. No, there's a 13-year-old who lives in London who takes fantastic photos.
Yeah,
Uh,
it is ridiculous, you know, but they pick up on things really fast. So, and
mm,
my question now is like particularly like Rod Stubbings, he lives in Australia too. So if you're planning to go there, look, I will hook you up with this man. He's really great. He has his own observatory. He has 22-inch Dobsonian,
oh,
and
wow. Okay.
yeah, so he does variable star observations,
Yeah.
and he been like. You know, his work has been in numerous papers and science, you know, research and things like that. So he's been involved. So he's right now a third or a second in the world. He did 350 plus thousand variable star observations.
Wow.
So, you know, and now I'm just thinking about, again, coming back to the point as we talked about science, you know, like professionals and, you know, scientists working in the financial industry or different industries, and the value that they can bring to the science field working, you know, in the science field back again. So now I'm thinking, how many of those astrophotographers can, you know, do observations, you know, just like, you know, Rod or Will, and they can provide maybe even more value to the science community. So like, what would you say, like it, would you recommend for somebody? Have you ever thought about that? Like, what do you think?
Well, I know that there are various sort of citizen science
Mm-hmm.
projects which sometimes ask for amateurs to point
Yep.
their telescopes up at the night sky and either take photos or make observations.
Yep.
I mean, I do find the observation side, you know, I think you've got to have good equipment for observations as well, right? I mean, if you've got a 22-inch Dobsonian, that's ideal for making observations. If you're looking at a wide field telescope, you know, you're going to be limited, especially if you're you know, in a Bortle Lake location where there's lots of light pollution. You know, it does kind of depend upon what you're being asked to observe. So, I mean, I'm all in favor of it because, you know, astronomy is one of the few areas of science where amateurs can still make a contribution. You know, I think, you know, Comet Borisov was an amateur astronomer with very good equipment. You know, so there are some things where amateurs can make their own individual contributions, but also these citizen science projects are quite useful as well. So, and you know, astronomy started out as an amateur profession. William Herschel, the original members of the Royal Society, were amateurs. So it has a long tradition of amateur involvement. And I guess to a certain extent, it's getting harder because the professional side of things is so much stronger these days.
Exactly.
So I think your face had frozen there, so I don't know if Zoom had cut me off.
No, I think that's I think we're good. Is this still recording? I think, right? Can you hear me?
Yeah, it's still recording. Yeah. It's just I think the image quality went down for a bit. Happens on Zoom, right?
Yeah. That's no worries. Look, technology. We live in this day and age of technology and Zoom calls. So I'm pretty sure today is what, it's Sunday. So probably there's another 13 billion people who are doing the Zoom call today. It's on this planet and other planets as well. So look, the question remains now, again, with all the work that you're currently doing. I mean, as I told you before, I'm a huge fan. Anybody who is involved in this industry, do the observations, astrophotography, or just continue to communicate the science to the people, because to some degree, this is a science communication. Because like all the people that come through your feeds and you see the engagement, the likes, like I talk with some people, I talk with a data research guy, he's a data engineer. And I said, all this data that are calling, likes and shares and comments, he's like, that's not a data. Well, it's a very simple data, because it shows basically that people engages with your, with your work. And, you're not going to see people come through your email and saying, oh my God, because of you, like I started this, I pursue my dream, I started this journey or whatever. But I'm pretty sure you're making an impact on people on that scale, or maybe even bigger scale. And it's been happening now for 2+ years. How long you've been involved with this, right now. So, and you continue to do that. So I really appreciate you, to taking the time to do this, because, for now, at least, guys and girls, you probably understood that sometimes it's really painful. The weather is not there, so look, but you just, you work things through, and, you do it, of course, for yourself, for your own personal curiosity, because you love space, you have passion for that, even though you're working in a financial industry, which is, again, it's a completely different topic, difficult. But look, it's, you understand how important that is, coming back from Apollo times, right? So.
Yeah, well, I think once you've got sort of a sense of wonder at the universe,
Yep.
You never lose it, right? I mean, I still feel sort of almost childlike when, I manage to photograph something, and I look up, I find out what that object is, what we know about it, and it just amazes me that we've got the technology now that we can, from our homes, visit the universe, because that's effectively what we're doing. And that, certainly for me, if I'm able to, in the future, I would like to go back and study again. So I might go back to university and do some kind of astronomy degree, and who knows, maybe I'll get a second career even after I retire. Who knows? But for me, it is about instilling showing people that this stuff is there, because otherwise a lot of people just wouldn't know. It's fine for us in the community, we see this kind of stuff, but I put it on our local Facebook groups for the area I live in, and people start asking questions, what's a nebula, what is this thing, is it real, did you computer generate it? And it's like, no, it's a real thing, and so you're sort of getting a message out there. And I've given talks at local astronomy societies and things, and it's all about engendering interest. And if it gets some people interested in science, then great.
Yeah, it's definitely that. As I said, as you just said now, and continue to communicate the science and continue to disrupt. Some communities, like flat Earth community and things like that, where
God,
people
don't start me on that. Right?
where people get misinformed, and again, part of that we have to blame the social media, because I understand that the information that is out there, people consume, like these days they go to the podcast just like this one, to YouTube, and somebody talks for 5 minutes and it's like the earth is flat. Okay, it makes sense, whatever, I'm just gonna roll with it. Like it stands on elephants. Okay, good. Look, so part of that is we continue to educate people in the right way, to actually show
Yeah.
them, look, this is what it is, this is what the planets, there's nebulas, this is what's happening in the universe. Because as you said, look, good for you, because you never lost it. As you said, you continue. I don't know how much what you did before. You probably read articles, books, or something related to astronomy, and then you got into, again, astrophotography. For me personally, I lost it, including probably millions of millions of people around the world. Because when you're young, when you're 7, what do you want to be? I want to be an astronaut. It's going to be up there: astronaut, fireman, doctor. But when you grow up, you go through the educational system. Is like, no, your responsibilities. You have to get a job. You have to do this and live your life. This is serious stuff, right? And people lose it. So for people to help them to understand, especially now in the COVID times, as I told you before, saying that it could be a good time, even though what's happening in the economy and for with the people's lives, that you can think about the future and where the space is heading. And actually, right now, it's being in that position where a lot of people are paying attention to it, because a lot of people are still not knowing what's happening in this industry. So opening their personal eyes and ears and saying, hey, listen, maybe you can be part of that. It's either through communicating science, being in astrophotography, sharing the work with other people and inspiring others, pursuing career in law, because space law is a big topic, medicine, engineering. I mean, there's spaces open for many different options. So letting people knowing that, and again, for me, the personal thing that I want to see, all these time frames. We used to have this in Apollo mission, like, and now huge time frames, 5 years, or Artemis mission. It's going to be always extending 4, 5, 10 years. Coming back to the fact, I don't have the patience. I wanna have millions of people working on this collaboratively and saying, okay, let's shorten the time frames. Let's go from 10 years to 2 years, 3 months, if possible, and let's achieve something great. So that's what it's all about. Because we have no clue what we're doing here, but hey, let's figure.
Yeah, and technology is going to help us get there as well.
Yeah.
It's always developing. I mean, I remember when I was an undergraduate and they were talking about the Human Genome Project, and what a huge task it was to map the human genome. And now we have technology that can do that in a fraction of the time. It's incredible how far we've come in 20 years. To think where we will be in another 20 years. I mean, I see some of the guys who were astrophotographers before digital, and they had the patience of saints to be able to take photographs of deep sky objects with film, because anybody, I mean, to the younger kids who never used film, right? I mean, it's you didn't know what you got until after you took the film and developed it. So it's none of this preview, I'll throw that away and I'll get it just right kind of thing. I mean, they must have had the patience of saints to do that, but they did it. And then digital came along, and now we've got this technology that enables us to capture the heavens from our back gardens, even in cities. So it'd be amazing where we'll be in another 20 years time. So I mean, I am confident that amateur astronomers and will be able to make a contribution, because that technology will be catching up on some of the professionals, and we'll be able to capture real data. And I'm a member of the British Astronomical Association, and people on there do some serious analysis. They do spectroscopic analysis of stars, and they are doing science, and they get that published in the journal. And so it is possible to do some amateur work with amateur equipment, albeit it may be slightly specialized, and contribute to the sum of mankind's knowledge.
Yeah. Look,
I'm optimistic.
Exactly. Me too. Look, me too. I'm very optimistic. And again, I see the rate of change and I see the rate of innovation for the technology. I ask the questions of the people who've been here, astrophotographers. What do you think about 3D printed telescopes? It's like, oh, this is not happening in another 30 years. And I'm like, man, you don't know. Like, this is already happening, So, but again, I love the fact that we're on a brink of, it feels like, at least, on a brink of what the Apollo missions was before. It feels like I wasn't here around, but at least as far as I read that, the documentaries that I watched, it was this rush. It's like, who's going to get there first? Who's going to be first in a space? Who's going to be first on? So now it feels like we're coming back on the same kind of, race to, but there's no competition again amongst the companies, maybe SpaceX, Blue Origin, and things like that. But the question that I wanted to ask, again, I don't want to ruin this positive talk of, the future is going to be great. But I want to ask you about the SpaceX. You mentioned Elon Musk, the
Yeah.
feelings that you had about that. So what do you think about the Starlink and the entire space debris satellite situation? Did you have
Yeah.
any problems with that so far? Do you think it's going to be a huge problem? What's your opinion about that?
Well, I mean, sometimes, yeah, when they're doing a launch, yeah, I mean, you can physically see them going across the sky, this train. In some ways, it's spectacular to see this sort of body of lights going across the night sky. And yeah, occasionally you're photographing and you get photo bombed by Starlink satellites, and that can be a little bit frustrating.
Yeah.
But I honestly don't know how disruptive they're going to be, because obviously at that point they're in quite low orbit, and the software we've got is quite good at removing satellite trails from images.
Mm-hmm.
I don't bother to remove images that have got satellite trail. The only things I remove are things where I've got a 747 that's flown overhead and I can see an actual jet engine in my image. That I'll remove. But satellites at the moment are not really a problem, but it's the vast number that they're planning to put up, and whether we'll be able to keep up with trying to see through that mass of satellites. Because when you look at those sort of computer projections of, here's the 2,000 satellites around the Earth at the moment, and this is where we're going to be with 30,000, and it's like, oh my God, how are we going to see through that? Maybe we will be able to, but maybe we won't, in which case we'll have lost a natural resource. It's already kind of worrying, how much light pollution has caused us to lose the night sky. And obviously it was Dark Sky Week this week. And I did do a thing on the local Facebook to say, look, 100 years ago, our kids would have looked up and said, here, see the Milky Way. We need to be thoughtful about how we deal with light pollution. But then if we fill up the space around the Earth with all these satellites, it could be a real problem. And obviously those satellites are there for a reason, a commercial reason, but they're also going to provide benefits to people on the ground. So it's weighing up those two technological developments, giving broadband to people in remote areas and in poor countries versus our ability to look out. Somehow we've got to find a balance between those things. And yeah, on the negative side, I think, there's the push to the moon and stuff. Obviously, like Apollo, there's a political rivalry going on there now. China's already landed on the moon a few times now, and the US wants to get there again. So it's almost like a space race again, which again pushes the technology and drives it forward. But it's a question of then the legal structure about ownership of the moon and the space between Earth and the moon. It's kind of unregulated, and whoever controls it probably will end up controlling a whole chunk of things here on Earth. So
1967, I think that's the paper that we have for the countries where they actually use to determine who space belongs to. Again, there's a certain agreement that says, okay, moon doesn't belong to anybody, this doesn't belong to anybody. The space is the space, right? So but it's been written in 1967 as far as I remember.
Yeah,
I mean, a lot of things changed. Not all the companies signed the treaty, so there's always going to be some villains amongst the good people who would say, no, I want to go and mine the moon, and this is already happening. Like, we have the companies. So we talking about space debris, huge problem. Now I'm reading an article. Well, actually, you talked about it. there's because I heard about UK company and it's called Astroscale. So they will be doing space debris removal, and this
Mm.
is it says Astroscale space debris removal demo set for launch. That's a BBC article, and it's been March 17, 2021. I heard about I think it's a Finnish company and a Japanese company. They're already doing space debris removal, but again, as you talked about, the number of satellites that are being launched, maybe it's not going to be a problem for observers just like yourself, astrophotographers, around the world. But what about the observatories? Let's say
Yeah,
where they're taking they're taking single exposures. They're looking at the thing right now, and the one that's being built right now, like extremely large
yeah,
telescope.
yeah,
Which is going to be the biggest one ever. I don't know the exactly dimensions of the mirror, but it's going to be, I think it's over 30 meters, which is going to be a phenomenal instrument for the science. That's what I'm getting concerned. Is this
yeah. I know, and they've already raised concerns about
yeah,
what the impact it's going to have on the research they're able to do.
yeah.
Um,
So that's concerning.
yeah,
But hey, look, it's all about it's coming back to the finance sector. Let's come back. Let's circle back around. It's all about the making money and who's going to be first, who's going to
yeah.
mine the
Space,
asteroids.
space is now a commercial
Yeah,
proposition for a lot of companies. So yeah,
yeah.
so
Look, we live again. We live in this economically driven, financially driven society where like SpaceX wouldn't be SpaceX where it is right now without all the contracts that they get, billion-dollar contracts from NASA. Okay, send us the cargo into ISS, with the supply stuff. So that's the way it goes, at least for now. Maybe at some point we're gonna figure some magic, maybe we're going to uncover some magic wand where we can do business without money, or it's a free society. We just do for the sake of exploration, right?
yeah,
Maybe.
yeah. Well, it'd be nice to jump forward sort of 300 years to Star Trek and be on the Enterprise, just doing
Exactly.
exploration.
Exactly. Look, who knows?
Yeah,
Who knows? So that's for the future to be determined. Again, if we're going to continue to look at the future, at least look from the positive lens, as we said before. Just
absolutely.
that's the right way to go. We don't know, and we don't have a crystal ball to project it. Look, so last question. I love the fact that you said you might go back to the university to get a degree. So that's very promising. Fingers crossed. Hopefully, we're gonna see
Yeah.
that. So look. So what do you think the overall story, the footprints that you took, just like with the Apollo mission, again Neil Armstrong, like what do you think is going to be your personal footprint and the legacy that you're going to leave here?
Oh wow. I'm far too humble to think I'm going to leave a legacy other than my children.
I told you,
I-
look, we don't know what's happening on social media, the impact that we make in so, but
yeah. I mean, my kids did not follow me into science. One is a lawyer and one works in finance. Um, but who knows? Maybe my grandkids will be scientists. Who knows?
yeah.
So yeah, I think each of us, it's our kids that are our real legacy. But I think they have grown up with a world that they know needs fixing.
Yeah.
So hopefully that's something they will take forward in their lives. And they do at least promote my Instagram feed for me. But no, I think if I can instill any interest in that sort of sense of wonder about the natural world, the universe as a whole, from the most microscopic thing to the most vast objects in space, it's all there for young people to build a career around, and hopefully take mankind into a better position, help us deal with climate change, all these challenges that we face, which partly are self-inflicted.
Yeah.
We hopefully those young minds will help us fix those problems. So
Yeah.
you know
I'm pretty sure this is already happening, because we have so many people, again, that I have privilege, including yourself, to have on the show and talk about what is happening in the space industry. And as I said before, don't think about, oh, we're talking about something that is gonna happen in the next 5 years. Like this is already happening right now. But
Mm.
a lot of people, it's not happening on a scale that like everybody knows. But when you're gonna go to the shop, to the clothing store, you're gonna see a lot of NASA t-shirts, shoes, and because of course NASA is being really great at marketing. They always been capturing public's attention, and that's happening, and it's all being done for the reason. Again, Artemis missions and things like that. We need to keep people's eyeballs on these because that's how the projects get funded.
Yeah.
So I do understand that part, but it's definitely happening. And again, with the help of people just like yourself who communicate the science in this way, if it's either through social media, coming on a podcast just like this one, and taking the time to talk about how important this is the part of the legacy. This is all we can all encounter that, and just mix it up with what's happening. Because again, as you said, we're not all going to be, oh my god, I did this in life, and this is like we're not always taking things for granted, or just
Mm.
understand the importance of the things that we do. But we all going to be part of very important change that's happening, and that's going to continue to happen in the future. So my big thank you again for doing what you do.
Well,
It's really
no,
important.
it's my pleasure. It's what I enjoy doing. So
Here you go. And that's the best. That's the best. When you can do the thing that you will enjoy, it's the best thing. And I think I do encourage people to think about what you just said, that you working, and again in this industry doing successfully what you do. Now you're thinking about, okay, maybe when I'm going to retire, I'm still going to pursue the astronomy side of things. I need to go back to university to get some degrees, and you're still coming back like to that. So my encouragement for the people who are sitting here and thinking about making that transition now, maybe they have access, maybe they're uncertain about their job in the company 1913 established, right? Gone. The industries are gone overnight right now in these tough times.
yeah,
So making that change, maybe it's a really good time for some people. As you mentioned, your daughter's law, big
yeah.
field, finance is going to be big, and there is a big field in the space industry too. So look, I encourage people to do exactly the same. Take a minute, think about the future, and if you want to be part of the future in the space industry. So
Yeah, well, the important thing is you go through life, you never stop learning,
yeah,
you know, whatever, even in my field, I work in a technology field, you always have to learn new technologies.
yeah,
Otherwise, you get left behind. So you have to keep that sort of mentality that when you leave university or college or whatever, there's always something new to learn, whether that's something that you do personally through reading books or through courses or work. It's always about learning something new.
exactly.
And I think that's as human beings, the greatest thing we've got going for us is we can always learn something new.
Yeah. And I learned a bunch today from you. So I really appreciate you for sharing all this great information. And look, guys and girls, before we're going to wrap this up, as always, I wanted to ask you if you share this episode to your friend. It's always appreciated because, again, my personal mission, as you probably understood by me talking 20 times on this podcast before, I just wanted to inspire more people to pursue their own personal careers or just to open their minds to what's happening in this industry and to at least be part of it to some degree. And again, Colin talked about a great entryways, just like astrophotography, which it is, and to get that inspiration going. So if you pass this episode to your friend, that's awesome. And again, guys, appreciate you watching, and I'll see you on the next episode. And until then, don't forget to keep exploring.